In college algebra, I made this table here so that we could refer to it as we answer these remaining three problems. So if needed, you could copy this down in your notes, although we already wrote it down yesterday. Just looks a little more concise right here. So on number 4, we need to write down the degree, and that is the largest exponent. So that is 3. And I'm looking at that 3 right there. That's the largest exponent, which is odd. You know, not weird. I mean odd in terms of that right there. All right. The lead coefficient is the number in front of that term, which is a 1. Right there. It's not written. It's that implied 1, which is positive. And that tells you exactly what the answer is if you look at the table. So you look at the right side of the table, odd, positive, and that is the end behavior. So left, it's going down. Right, it is going up. Let's try number 5, or maybe hit pause and you guys do number 5 and 6 and see if you get the same as me. All right, number 5, n is 4. Lead coefficient is -1. That means on the left side, it is going down. And on the right side, it is going down. For number 6, n is also 4 with a lead coefficient of 1. So that tells me on the left, it is going up. On the right, it is going up. All right, hopefully that helps. We moved on to factoring practice after that. So we jumped over to this document here. And I tried to give you some reminders about how to factor. So if you're given a problem and they ask you to find the zeros, the solutions, factoring is the way to go most of the time. Make sure you look for a GCF. Something else I told the class, if you don't want to factor, if the largest exponent is 2, then the quadratic formula will always work. So let's use f of x. That's given this scenario. We have a number in front of x squared, a number in front of x, a number by itself. The quadratic formula is -b plus or minus b squared minus 4ac all over 2a. All right, I'm going to erase this into my parenthesis there. And we're going to factor. So I'm just giving you another option instead of factoring. For this first problem, I see 2 terms. And I'm asking myself if maybe it's difference of 2 squares. But if I am asking that question, I've already skipped my first hint. And that is look for a GCF. All right, always look for a GCF. And sure enough, a 5 goes into both of those. You want the biggest number that divides into them. They both have an x, so I can take a 5x out. And then I write a parenthesis with the leftover. So you have to think backwards here. 35 divided by 5 is 7, and there's still an x on that term. Negative 15 divided by 5 is negative 3, and that x is gone. So at that point, we are actually done factoring, because there is not an x squared term. There's no factoring to be done. So you're actually kind of done. Now, up here at the very top, it said find the zeros. So that means set each factor equal to 0. So that means set 5x equal to 0. Let me add and solve. And set this factor equal to 0. This part I hope is pretty easy. It's just easy to forget to do it. On that first one, you divide both sides by 5, and x is 0. On the second one, you add 3 to the other side, divide by 7, and you get 3/7. So number 1, I hope you think is pretty easy, not bad. Take out a GCF, set each factor equal to 0. Number 2 is 3 terms. So up here, oh, by the way, I skipped over this hint right here. If you have 2 terms and an x squared term, it might be difference of 2 squares, because those, you can square root both of those. So to factor that, you do this. All right, so just a reminder, if it's 2 terms, but this is 3 terms. So we're looking right here. And you might need to use the box method or something else, some clever method a teacher taught you, if the front number isn't a 1. But look at number 2, the front number is a 1. This is very easy. Box method is not necessary. All you need to do, let's change colors. All you need to do for this problem is find 2 numbers that multiply to negative 21 and add to negative 4. Some people like to make a little table and write something like this. And hopefully you're thinking of negative 7 and 3. Because when you add those up, you get negative 4. So our answer on number 2, or sorry, our factoring is x minus 7, x plus 3. To solve the thing, to find the zeros, you set each factor equal to 0, and then you're about done. All right, the ugly example is number 3. Let's give it a shot. So I see a number in front. If it's me, I either do guess and check, or the box method. So I would just write down the method you like. I'm just going to show you the box method. Guessing and checking, I mean, what you're trying to do is you make your two parentheses and you're trying to just literally write the answer. It's pretty easy at first because you know you need an X and an X, but then you're literally guessing, and the hard thing is getting this middle term to work. Let's go ahead and try and guess and check. So, for example, 2 times 9 gives me 18, and 2 times -2 gives me -4. This looks like it works, but it doesn't, because the inner plus the outer does not equal 21x. So this doesn't work. You can keep playing with the numbers and eventually you'll get it. It's like a Rubik's Cube. You keep trying numbers and maybe it'll work. But the box method always works. First, multiply first times last. $18 times -4. And I got -72. Second step, find two numbers that multiply to -72 and add to 21. So some people like to make a little table, like I showed you earlier. And long story short, do a bunch of trial and error, maybe try 8 and -9, that doesn't work. But 24 and -3, that works. Multiplies to -72 and add to 21. So at that point, that I think is the hardest step. Make a box. First term in first spot. Last term in last spot. Two numbers found. In remaining spots. So, let's make our box. I think I have room down here. First term in first spot, 18x squared. Last term in last spot. I found 24 and -3. Technically, these are supposed to have x's on them. It doesn't matter. You could have flipped 24 and -3. That doesn't matter. But if you're worried about the math, technically they're supposed to have x's on them. I don't really care if you write an x there. But earlier, I tried 2x and 9x, and the reason why that didn't work, even though it looked like it would work, is because I can't write a 2 here or a 9 to multiply and get -3. So 2 and 9 just won't work. So I need two other numbers that multiply to 18. I want a 3x and a 6x, because I can go 3 times -1 to get -3. I can go 6 times 4 to get 24. And sure enough, 4 times -1 gives me -4. So if you get that far, you're just about done. It is now factored. Now just solve for the zeros. So 3x plus 4 equals 0. 6x minus 1 equals 0. And you got it. All right, long problem. Sorry for the long video. See y'all later. Bye.